Okay, okay, we'll see today's class. We already seen beam element of the stiffness matrix. So now very easy topic and basic topic, axial element. So we'll see axial element. Okay, axial element. So what it is means by axial element? What it is mean by axial element? Only axial force. That's it. Only axial force is taken. That is an axial element. Only axial force is taken. Okay. So see, in the basic strength of materials, you already studied what is an axial force, axial stress, axial strain, and Young's modulus relations. You already know. Just take an one element. This is an axial element, I think. So two nodes, one node, two nodes. This is one element, element one, two nodes. Only axial force is taken. Okay, only axial force, no bending, shear. So we will write for this we will write for this uh, we will write for this stiffness matrix. So two nodes, it has a kinematic indeterminacy is 2. So u1 and u2 is the nodal displacements. U1 u2 are the nodal displacements. Give a unit displacement at the location of 1. Give a unit displacement. Give a unit displacement 1. Unit displacement. Don't allow displacement in the second direction. Just arrest it. Arrest it. Give a unit displacement in the direction of 1, in the direction of this towards right. Unit. How much force is required or how much force develop? You already know. AE by L. So otherwise, if you see, it is PL by AE is the displacement, is unit, 1 unit. So unit force is what is the force? P is AE by L. It's in the direction of displacement only. So okay. So on how much force is generated at the direction of U2? So this force, same equilibrium equation, just check it is. This is also should be equal to AE by L. So this element characteristics A, E, and it has a length here. AE by L. AE is the axial rigidity. You already know. AE means axial rigidity. So EA is flexural rigidity. You already know. Shear rigidity, torsional rigidity. You already know these terms. So that for that you can check it is K11 is AE by L, K21 is minus AE by L. This direction, opposite direction. Okay, same for the same element. Now apply a unit displacement in the direction of 2. In the direction of 2. Don't allow displacement. Arrest the displacement. How much force is required? It's AE by L. This is AE by L, equilibrium. So now comes to the tip. K12 is minus AE by L. K22 is AE by L. That's it. Only axial force. Nothing. So now write down stiffness matrix for the axial element. AE by L minus AE by L minus AE by L, AE by L. Diagonal elements must be positive because the force generated in the direction of the displacement only, not in opposite direction. That's applicable in any way. Okay, so this is a force force per unit displacement. How much displacements? Nodal displacements u1 u2 is equal to the p1 p2. So don't ask for fixed force vector in the beam element. In this there is no fixed force vector. Those are terms are not existed in this. Okay, this also existed. Those are the secondary stresses we will discuss in the problem. So okay, k u equal to p. Otherwise you can check outside, you can ae by l, you can get out 1 minus 1 minus 1 1 u1 u2 equal to p1 p2. So this is, if you see these are the two axial elements, 1 u1 u2 u3, 1 2 two elements. It has a characteristics of a1 e1 and l1, a2 e2 l2. So for the first element, so this is a1 e1 by l1, 1 minus 1 minus 1 1 u1 u2 equal to p1 p2. This is the equation, local elemental matrix. For the second element, a2 e2 l2, 1 minus 1 minus 1 1 u2 u3 equal to p2 p3. This is a second element. This is the first element, this is second element. Now comes to the global elemental matrix. Global matrix, how can you just add these two equations? This is also p2, this is also p2. Add these two, that's it. So now a1 e1 by l1, a1 e1 by l1 minus a1 e1 by l1 minus a1 e1 by l1 plus, so again a2 e2 by l2 minus a2 e2 by l2 minus a2 e2 by l2, a2 e2 by l2. So 0 0 u1 u2 u3 is equal to p1 p2 p3. That's it. K u equal to p. Understood or get it? See, what is this equation? This equation is, see, just we write combined of these two, we just combine, just addition, nothing more than this. Just add it. p2 has, from this element p2 has certain reaction, and this element also p2 has reaction. So just add it, nothing more than this. Okay, this is the global. So we now you can add number of elements. You can add number of elements and you can solve it. Apply a boundary conditions. Final thing, apply a boundary conditions and solve it. That's it. This is also same in finite element analysis also. Okay, finite element analysis also same procedure. So that's it. So now we will see some of the problems you can understand better way you can understand it. Okay, so first problem, I will check it. First problem, one kg, 10 centimeters. It's also 10 centimeters. Area 2 centimeter square. This is 1 centimeter square. And Young's modulus is 2 into 10 power 6 kg per centimeter square. Analyze the axial element. Analyze the axial element. Analyze means you have to find out the displacements displacements at the locations, and reaction at this location. By the strength of materials understanding, you can easily say this is also 1 kg. You can get it as a reaction also 1 kg, because there is no another additional forces in between. This is 1 kg, you also get is like this 1 kg. You can get it the displacement here also, PL by AE. You can get it. This element has 1 kg, this element has 1 kg force by area, stress, displacement PL by AE. You can easily get in within seconds. But how to solve in finite element analysis, now we will see. That's the problem. Okay, so now take it. So I will choose, this is a node L1, this is node 2, this is node 3, this is element 1, this is element 2. So you can solve it in seconds in by strength of materials understanding, but in finite element analysis you will see the problems in step by step. Okay, step by step understanding, you can solve more complicated problems in finite element analysis easily, or finite element analysis or matrix methods. Okay, so now we'll see first element. I will write a stiffness matrix equation a1 e1 by l1 1 minus 1 minus 1 minus 1 u1 u2 is equal to p1 p2. So what is a1 e1 by l1 value? What is the e1 a1 l1 value? So write down 2 into 10 power 6. A is 2, L is 10. So 4 into 10 power 5 kg per centimeter. Okay, so that is the first equation, first elemental mat. For a first element, it is a matrix equation. For second also a2 u2 by l2 1 minus 1 minus 1 1 u2 u3 p2 p3. This is the second equation. So what is a2 u2 by l2 value? E value, so area 1 divided by length is same, so 2 into 10 power 5. So global max combined, so this value is 4 into 10 power 5, this value is 2 into 10 power 5. I will outside 10 power 5 and write the equation. See, it is 10 power 5 4 minus 4 minus 4 4. So now second plus 2 minus 2 minus 2 2. That's it, no? That's it. 0 0 u1 u2 u3 equal to p1 p2 p3. That's it. K u equal to p. Local and global, this is like algorithm. No need to do extra equations. It's like a flow algorithm. One step, local elemental matrix and global elemental matrix, global elemental equations, and apply a boundary conditions, get the results. Now you can see boundary conditions. What are the boundary conditions here? So what are the boundary conditions here? See, so u1 is 0. Are understood? There is no displacement at the nodal there is no displacement at the location of node 1. Are understood? So u2 u1 is 0. So, and also see p3 is 1 kg in the same direction, right side direction. p3 is 1 kg. And also you can see there is no load at p2. There is no load at p2. Are understood? There is no load. So 0 load. So p2 is 0. Those are the boundary conditions. Now you can solve the remaining equations. What are the remaining equations? you can find out the u2 and u3. Two equations, two unknowns. Two equations, just two equations. You can try it out. So 6 into 10 power 5. So otherwise 10 power 5 outside. 6 into u2 minus 2u3 into 10 power 5 is equal to 0. Next equation, minus 2u2 plus 2u3 into 10 power 5 equal to 1. So those are the two equations. Okay, two equations, two unknowns. Solve it and you will get you will get what is it. So just see this, you can multiply with these three, you can multiply with, you can see, you can just multiply with this equation with respect to 3. You can get minus 6u2 plus 6u3 10 power 5 equal to 3 plus 3. Add those two, how can get, you can get it 4u3 into 10 power 5 equal to 3. So u3 equal to 3 by 4 into 10 power minus 5. So what you will get, u3 equal to 0.75 10 power 5. So it's 3 kilonewtons are understood. 3 kilonewtons. What is that? It's 1 kg. Okay, kg is 1 kg. It's a 10 power 5 are understood. Kg per centimeter, kg per centimeter, kg per centimeter. What is it? Okay, you will get it's 0.75 centimeters, 0.75 centimeters. Okay, sorry, no, okay. So 10 power 5 kg per centimeters, kg per centimeters. kg per centimeters. Okay, what is u2? u2 you will get 0.25 centimeters, 0.25 centimeters. So okay, these are the nodal displacements, not these displacements in the elements. These are the nodal displacements, u2 and u3, Now comes to the p1. What is that p1 value? You can just check it is first equation, 4 into u1 minus 4 into u2. Understood? Minus 4 into u2 and 0 into u3. Okay, so directly you can find us minus 4 into u2 into 10 power 5 equal to p1. Understood? Into 10 power 5. So what is u2? u2 is 0.25. So 0.25 into 1. Okay, 0.25 into 1, what is that? 1 kg. So otherwise these are the values are 0.75 into 10 power minus 5 centimeters. Okay, 10 power minus 5 centimeters, not 0.75 centimeters. 0.75 into 10 power minus 5 centimeters. Okay, so now it comes to the 0.25 into 10 power minus 5 multiply with minus 5 multiply with 5. You can cancel it, it will get its minus 1 kg. Okay, that's the p1 is minus 1 kg. So what is that means? Minus means what? This is we taken as a positive. This direction towards right side is a positive, towards left side is a negative. Okay, so now comes to the one Get it 1? We already know it is 1 because there is no another forces in the middle of the members. It is a 1, should be it's equal to 1. Understood? So on u2 displacement, nodal displacements, you get it. u2 is 0.25 into 10 power minus 5 centimeters. u3 is 0.75 into 10 power minus 5 centimeters. Now see what is the displacement. What is the displacement in the member 2? In the member 2 is not 0.75, not 0.25. It's a u3 minus u2. Understood? u3 minus u2 is the displacement in the member. Simple logic, if you see, it is two members. It's two members. It first member is displaced this much. Second member, it was this length. So what is the displacement in the member 2? Not this much, not this much. What is the displacement in the number 2? This minus this. Are understood? Then only you can get the displacement in the member 2. By this displacement, you can find out the strain. Strain multiply with stress. Strain multiply with Young's modulus. You can get stress. Okay. So analyzation means strain and displacements, reactions, and finally find out the stresses also. Sir, can you find out the stress? Okay, we will find out the stress, but we will see for the next problem. Next 2-3 problems we will see the strain and stress also. Okay, for this problem is just elementary problem, that's why I left. Now we will see the second problem and third problems also. Okay, one by one. So now comes to the second problem. Second problem. Analyze this axial member. This is the second problem. See, he given 60 kilonewtons is load, area is 250 mm square for the both elements. Young's modulus is 20 into 10 cube Newton per mm square. See, 60 kilonewtons acts at the center. So now we will took these are the three nodes. This is the one node, this is the second node, this is the third node. This is the third node. This is the first element, this is the second element. Now we can observe it. If the displacement of the member is exceeds 1.2 mm, it will get a stress or it will experience a force. Otherwise, if the displacement of the member is less than 1.2 mm, there is no stress. Understood? Just see it is. If it is if the displacement in the member comes to this much, there is no extra repulsive force because there is no touching. Otherwise, our answer, there is no restraint of the displacements. If something displacement is restrained, then only the force is experienced or force is developed. You already know in the temperature stresses, if the temperature is increasing, this member is increased its length. If you control or restrain the displacement, then only gets the force. Otherwise, it freely expands it. There is no force at all. Here also, if you apply a 60 kN force here, the displacement of the member exceeds 1.2 mm, then some of the displacements, though the displacement is allowed is only 1.2 mm, the displacement is exceeds 1.2 mm, so you literally restrain certain displacements. For that the certain displacement restrainment, you experience a certain force. Otherwise, if the displacement is less than 1.2 mm, there is no force at the location of node 3. There is no force at the location of node 3. So if the displacement is less than 1.2 mm, you just directly to the 60 kilonewtons, it comes to the 60 also. That's it. Just 60 60, that's it. There is no force in the member element 2. So this is, I took element 1, this is element 2. So the member, so force exactly applied at this location means the force or stress or strains experienced only element 1, there is no element 2. Understood? Because if you hold at the off and you stretch it, so only this part will get the one experience of forces or stress or strains. There is no stress or force in this element. But if you see the displacement of this member exceeds 1.2, exceeds 1.2 mm. So it has allow only 1.2 because it's a rigid plate. You arrest or you restrain certain displacements, so automatically certain force is exerted. Okay, so that's the idea. So now you can see what is the displacement, what is the displacement experienced in the member element 1. See what is the tail displacement, PL by AE. So P is what, 60 kilonewtons, L is 150 mm, not 300. See, only this part has displaced because the force is applied at center. 150 mm, area is 250 mm square, E is 10 into 10 power 3. So what is that value? This value is exactly 1.8 mm. 1.8 mm. So it is greater than 1.2 mm, but you allowed only 1.2 mm. Certain 0.6 mm is restrained. For that restrainment, you get a force. Understood? Exactly. You see, if it is member, it's there. If you increase the temperature, so it has certain displacement. It really displacement is there. If you increase the temperature, it will go. It will increase its length, or it will experience certain displacement. But you arrest this, you will get a compressive force. You already know it. Okay, understood? So same like this. So okay, now it's the 1.8 mm. So compulsory, so displacement is higher than the what we allowed. So certain displacement is restrained. So 0.6 mm is restrained. For that restrainment, you experience a certain force. So we will solve it. So nothing more, just what we seen previously, same thing. So AE by L, I will write what is AE by L value. So AE by L, what is A? 20 into 10 power 3. E is what? E, how much it is E? E is 10. Area is 250. L is 150. So once again, I will took this is element 1. This is element 2. Because see, both elements have same A, E, L. 150, 250, 20 into 10 cube. So no need to do each element, local elements. I will directly write the global element matrix. Okay. So what is that value? That value is, that will sorry, so 250, 3 is 5 is 100, 33 point, what is 33.33, 33.33 kilonewton per mm. Okay, so now I will write directly global elements. 33.33 10 cube is a global. 1 minus 1 minus 1 1 plus 1 minus 1 minus 1 1 u1 u2 u3 is equal to p1 p2 p3. Understood? Because element 1 and 2 has same AE by L. Okay, so that's it. So apply boundary conditions. What are the boundary conditions? What are the boundary conditions? Boundary conditions is, see, u1 is 0, u3, see u3, how much displacement of u3? You already know, you allowed only 1.2 mm. For that case only, it's the p3 will develop. Okay, u3 is 1.2 mm. Understood? That's the only thing here. And see, p2 is what? 60 kilonewtons. Let's say 60 kilonewtons. P1 will get a value and P3 also will get value. Okay, so that's the only thing we'll add it. So solve it. So only unknown value is u2. So solve second equation. What is the second equation? So second equation, minus 1 into 0, so 2 u2 minus 1 into 1.2 multiply with 33.33 is equal to 60 kilonewtons. So kilonewtons and 10 cube discharge. So what is u2? What is that u2? u2 is 1.5 mm. u2 is 1.5 mm. 1.5 mm. So and also you can check it is what is p1 value. p1 value is 6. Check it is minus 1 into u2, 0 into u3, only 1 into u2. Okay, 33.33 into 10 cube minus 1 into u2. u2 is 1.5 mm is equal to the p1. What is that p1 value? 1.5 into 33.33. So what is the p2 value? Sorry, p1 value. So 33 into 1. It's 50. So approximately 50. So what is p3 value? Just check it is p3 value. So minus 1 into u2, 1 into u3 equal to p3. So what is that value? That value is 10 kilo. That value is 10 kilometers. 15 plus 10 is 50 plus 10 is minus 50. Also you will get minus value. Okay, 50 plus 10 equal to 60. So if you see, if you want to write down the free bodies, so these are the three unknowns. You will get it, one thing and two and three. So later you can get it as strains and displacements. Strains, stress, you also get it. I will show that for the next problem. So if you want a free body, see, one thing is for the element 1 it's a 50, it's a 50. For element 2, for element 2, see, it is for element 2 it's a 10, it's a 10. Understood? These are the, you get it, 10 minus value, 50 minus value. So now see the joint. Now they see the joint. Sorry. See, it is in it is in a compression. Understood? It is in compression. It is in tension. Understood? It is in a tension. Compression and tension. See the giant value. What is the giant value? It's a 60. Are understood? 60. Exactly matching. Exactly matching. So that's it. So should be equal to p1 plus p2 equal to 60. So if you know one value, you can easily find out the second value. It's the second value is 60. G 10. One is 50 and second is 10. So are understood the free bodies? It's a compression and it's a tension. And also the displacement at the joint u2 is 1.5 mm. So nodal displacements, u3 nodal displacement is 1.2 mm. Okay, so that's it. That's the idea of second problem. So now comes to the next problem, third problem. So now comes to the third problem. Third problem, it's a1 and a2, distance is 300 mm, it's 400 mm. The load is applied at center, 200 kilonewtons. E1 is 70 into 10 cube. Newton per mm square. E2 is 20 into 10 cube Newton per mm square, and area 1 is 2400 mm square, area 2 is 600 mm square. Analyze the axial element. You already know this is a problem also in strength of materials. If you see it is this 200 kilonewtons is shared by the element 1 and element 2, and also you can see the displacement in the element 1 should be equal to the displacement in the element 2. I understood how much expand in the element 1 is same equal to how much compressed in the element 2. I understood. If you apply a force here, see certain element 1 is in tension and element 2 is in compression. So how much stretch in the element 1 is exactly equal to how much compressed by the element 2. So you already know in the strength of metals P1 plus P2 equal to, you can write down 200, and the displacement 1 and displacement 2, PL by AE 1, PL by AE 2, A2, A2, P1, P2. You can solve these two equations. You can get what is the P1 and P2. Okay, so that P1 is this exactly, so that P2 is exactly this. Second element is in compression, first element is in tension. You can directly see by the image, and these two equations you can solve it, you can get it by strength of metals. But now in the strength and finite element analysis we will see it is okay. Same this is, once again I will write it. This is node displacement 1, node 2, node 3, element 1, element 2, element 1 and element 2. Okay, so first element I will write it again, no need to write it. I will write what is AE by L. Our first element 1 minus 1 minus 1 1 u1 u2 equal to p1 p2. What is the AE by L for the first element? So 70 10 cube by area 2400 divided by length is 300. What is that value? 56 into 10 power 4. So Newton per mm. Newton per mm. So second element also same. AE by L 1 minus 1 minus 1 1 u2 u3 equal to p2 p3. Second element, what is AE by L value? So you will get it. So 20 10 power 3, next is area 600, length 400, 2 2 0 2 3 0 3. It's 3 into 10 power 4 Newton per mm. So I will write the global matrix. Directly. You can write it. So 10 power 4 I put outside. 56 minus 56 minus 56 plus 56. Second element add plus 3 3 minus 3 minus 3 3 0 0 u1 u2 u3 is equal to p1 p2 and p3. That's it. Same thing. So now comes to the boundary conditions. What are the boundary conditions? You can see u1 is 0 and u3 also 0. Understood? So those are the fixed. u1 0, u3 0, and p2, what is that value? 200 kilonewtons. 200 kilonewtons. Okay, so now solve it. Solve it. Only second equation, u2 is the unknown value. Solve it. What is that value? 58 into u2 minus 3 into 0 minus 56 into 0. So 58 10 power 4 u2 equal to 200 into 10 power 3. So what is u2? u2 is what? It is what? 0.34 centimeters. Centimeters or mm? I think mm. 0.34 mm. So 3 cancel. 200 divided by 580. So 0.34 mm, because everything is in mm. Newton per mm square, Newton per mm square. So these are the Newton per mm. These are the, okay, RC 10 into 10 power 4 into 8, it's Newton per mm. So Newton per mm multiply with U2 equal to P2. So you will get only mm. Okay, 0.34 mm. So now comes to the P1. What is the P1? Sorry. What is the P1? Check it is 56 into 0 minus 56 into U2. 0 into U3. You will get, what is the P1? What is P1? What is P1? So minus 56 into 10 power 4 into U2 is 0.34. What is that value? 56 into 0.34. So you will get is almost approximately 190 kilonewtons negative. So what is P3? Same P3 you will get it minus 3 into U2, 3 into 0. So 3 into U2, so 10 power 4, 3 into 0.34. Okay, that was it. 10. You already know P1 plus P2 equal to 200. Okay, so now you can see that. So this is a 190, this is a 10. Both are negative, no? Both comes to negative. Both comes to negative. If you want to write a free body, I will see the free body. I will see the free body. It's a 190. It's a 190. So second element you can see it's a 10. It's a 10. 10. You can see the joint. You can see the joint. It's exactly 200. Where comes to? Are you see? Are you see that? Exactly 200. So that's thing. That's thing. Now you can see for this element, for this problem, we will see the stress also. What is the stress? Stress. What is the stress? Strain into Young's modulus. Okay. Strain. What is the strain? Strain equal to what? Strain is displacement divided by length. Displacement is what? Displacement, you can write it. Displacement divided by original length. For that, if you see the element 1, for that element 1, what is the displacement? What is the displacement of the element 1? Element 1 displacement is, you can see, u2 minus u1. Are understood? This is the element. What is the displacement in the element 1 means u2 minus u1. And then exactly. So if the displacement is u2 minus u1, for the element 2, what is the displacement? u3 minus u2. I already said u2 and u3, u1 are not displacements in the elements, it's the displacements of the nodes. That point is displaced. How much the displacement is point? That point is displacement. If you see, this is the element. If this node 1 is displaced 0.5 mm, node 2 is also displaced 0.5 mm, that means what? It will go like this. This is a 0.5, this is a 0.5. That is total member is moving. There is no displacement in the member. Understood? So the displacement in the member, the elongation or the compression in the member means u2 minus u1. If both has same value, that means the total member is displaced. There is no displacement in the member. Understand? Okay, so that's thing. If it is 0.6 mm, it's a 0.5 mm. That means the member displacement in the member is 0.1 mm. The for that displacement only stress and strains are developed. Okay, if both nodes has same displacement, that means it is just moving. There is no displacement in the member. Okay, so that's thing. So if you see, strain is u2 minus u1 divided by length. Understand? u2 minus u1. We will write in the matrix way, Young's modulus divided by length u2 minus u1. Okay, so I will write u2 minus u1 in the matrix way, Young's modulus divided by 1 minus 1 1 u1 u2. You can see column, so row into column, you will get it minus u1 plus u2. Let's say u2 minus u1 na? So this is a stress matrix, stress representation in the matrix. So if you see, now you can see stress in the element 1 is what? Young's modulus of the element 1. Element 1 is 70 10 cube Newton per mm square divided by length of that first element is 300 minus 1 1. u1 is 0, u2 is 0.34 mm. So 0 into 3.4. So first element, how much is displaced? u1 is 0 na, u2 is 0.34 mm. So that's a 0.34 mm. That's it. So now comes to the, what is that value? That value is 79.33 Newton per mm square. That's the stress. Okay, that's the stress, you will get it. So element 2, so 20 into 10 cube Newton per mm square divided by 400 minus 1 1 u2 u3. That's it. Element 2 is u2 u3. So what is that value? This value is 17 and minus, you will get minus. So u3 is 0. You already know u3 is 0, u2 is 0.34. You will get minus. That's the compression. You already know this is the compression. This is the tension. Okay, this is the tension. Okay, that's it. Those are the problems. So now comes to the last problem, temperature stress problem. Also I will show the temperature problem also. So this is also same problem, but I will choose a lengthy problem. This area is 15 centimeters square. This area is 24 centimeters square. Okay, so and it's applied is 10 kilonewtons. Here it's applied opposite direction, 20 kilonewton, and length is, it's 75 centimeters. Up to this it's also 75 centimeters, and it's 60 centimeters. Okay, 60 centimeters. Young's modulus of everything is 20 into 10 power 6 Newton per centimeter square, and temperature rise the whole system is 10 degrees Celsius, and thermal coefficient alpha is 11 into 10 power minus 6 per centimeter per degree. Okay, so this is the idea. this force is also acting in the element, and the temperature also rise. See, it's rising. Okay, it's rising. It's rising. Okay, so we will include forces and temperature. We will do a problem only temperature stresses, but we already did by forces also. So we will include both. Once again, analyze the beam. Analyze not a beam. Analyze the axial element. I will choose three elements up to this. So nodes. This is one node u1. This is a second node u2. This is third node u3. This is u4. Elements. I will choose this is the first element. This is second element. This is the third element. Understood? Three elements. We'll see the large problem. For the first element, I will write elemental matrix A1 E1. First element AE by L value. See what is that value. First element AE by L is for A15. So see, directly I will write 4 into 10 power 6 Newton per centimeter square. Okay, I will directly write 4 into 10 power minus 10 power 6 1 minus 1 minus 1 1 u1 u2. So now comes to the topic. This value equal to p1 p2. Sir, what is that value? What is that value? If temperature is increasing, temperature is increasing, for the temperatural increment, it has experienced a certain force. So what is that force? If you see, this is an element, this is an element, this is an element. If the temperature is rising, what will happen? What will happen? It try to expand it, but the displacement is restrained. Displacement is restrained. How much force is experienced? How much force is experienced? The temperature is raised by delta T. It has a thermal coefficient alpha. How much force is experienced? You already know it. So how can you know it? So so force is exactly equal. Force is what? Strain into Young's modulus. You already know it. So what is the strain? How much strain? How much strain we restrain it? It will develop by a force. It will convert into a force. How much strain we restrain? Strain is what? Strain is what? Alpha temperature rise into L. So into everything. So alpha T L is the displacement experienced when we allow the temperatural displacement, but we restrain the displacement, it will convert into a force. How much displacement we restrain? This is the displacement is restrained divided by length. It will get a strain and Young's modulus. Understood? So LL you can cancel it. Young's modulus, temperature rise, and thermal coefficient, it's equal to a force. Are understood? So for the first element, how much force? For the first element, how much force we restrain? Sir, there is no restraint, sir. We allowed at U2, sir. We restrained only at U1. You feel that. But that effect, how much is restrained? See, we allow at U2. And for that element 2 also, allow at U2 and allow at U3. But it completely not allowing certain value restraining, because if you see U1, U2, U4 is restrained. So certain value in element 1, certain value we allowing, certain value is restrained. Element 2, certain value is allowing, certain value is restrained. U3. So the total displacements in element 1, element 2, element 3 is equal to what? Is equal to 0, because there is no displacements allowing. U1, U4 is 0. So certain, if higher force is exerted in the element 1, it will push the element 2, or higher force element 2. So those are the rearranged. So we will write each one equation. We will go through a global equation. We will apply boundary conditions. They will get the answer. We will get the answers. Don't feel that we are allowing at U2 and we are allowing at U3. We don't know how they rearrange it. Okay, just don't feel the complicated process. Just feel it. Okay, just see it. This is a very normal thing. For the first element, how much force is element? How much force? Temperatural force is exerted. Alpha T and Young's modulus. Okay, for the first element. For the first element force. For the first element force. So sorry, this is a stress. Young's modulus into strain equal to, you will get only stress multiply with area, only you will get a force. So area, understood? Area also. So what is the temperature thermal coefficient? 11 into 10 power minus 6. Temperature rise is 10. Young's modulus is 20 into 10 power minus 10 power 6. Area of the first element is 15 centimeters. So how much you will get? You will get 33 kilonewtons. 33 kilonewtons. For the second element also, where is this thing? Totally complete. Completely vanishing. Completely erased. Completely erased. Don't fear. I will write quickly. Okay. I will write quickly. I will write quickly what we. Let's say 10. Let's say 20. 15 centimeters square. 20 meters square. So Young's modulus is 20 into 10 power 6 Newton per centimeter square. Delta T is 10 degree. Alpha is 11 into 10 power minus 6 centimeter per inch. So I will do, this is U1, this is U2, this is U3, this is U4, element 1, element 2, element 3. For the element 1, we write in equation. For element 1, AE by L is, what is that value? 4 into 10 power 6 Newton per centimeter square. 4 into 10 power 6, 1 minus 1 minus 1, 1, U1, U2 plus something, temperature, we reserve for the temperature, P1 and P2. So for the temperature force, how much experienced in the element 1? For the temperature, alpha T Young's modulus into area. How much it will get? How much it will get? Let's say 33 kilonewtons. So what is the sign? What is the sign for 33 kilonewtons? Now you can see. For the element 1, the temperature is up increasing, the displacement in the direction. This is the displacement. We restrain this displacement. Force, what is the force direction? Force direction will come this direction with force. Compressive force will come. Understood? Compressive force will come. So this is the direction for the. So you can write it. What is that value? 33. So both directions will experience same. So rearrange it. Later it rearrange it. We will see the global matrix equation and later apply boundary conditions. First we will took element wise. So both the ends will get the same force, temperatural force. For the element 1, what is that value? 33 kilonewtons in this direction, and this is the direction. So this is the 33, this is minus 33. I got the point. So this is a temperatural force. This is a force, this is a force, this is the force. Responses are understood. So this is the idea. So now comes to the second element. Second element has also same 4 into 10 power 6, because the length, the area and Young's modulus both are same. 1 minus 1 minus 1 1 u2 and u3 comes to the temperatural stress also. Temperatural stress F2 what will get? F2 also element 2 also same length. So length I will write 75 centimeters. 75 centimeters. This is 60. For element 2 also same length, temperatural increment and thermal coefficient, everything is same. So you will get it 33 minus 33 is equal to P2 and P3. This is also 33. For element 3, F3, its length change are understood. Alpha T E A. Its area change 60. Its area change 60. So what is that value? You will get the value is 52 point. See, sorry. Area is 24. Area is 24. Previously area is 15 centimeters square. It's a 24. This value is 52.8. So, and also for element 3 AE by L. For element 3 AE by L is always value is, you will get it 8 into 10 power 6 Newton per centimeter square. AE by L. See, A is increasing, L is decreasing, something AE by L. So for element 3, 8 into 10 power 6, 1 minus 1 minus 1, 1, U3, U4. So we will get 52.8 minus 52.8 equal to P3, P4. So 1, 2, 3 elements, and now we can write down the global matrix. Can you write it? So 10 power 6 I will get outside. 10 power 6 I will get outside. So 4 minus 4 minus 4, 4 x 4 minus 4 minus 4, 4. Now comes to the 8 minus 8 minus 8, 8. So 0, 0, 0, 0, 0, 0. U1, U2, U3, U4 plus 33 minus 33 plus 33. Second element. Minus 33 for the third element. 52.8 minus 52.8 is equal to the P1, P2, P3 and P4. So that's it. KU and temperatural forces equal to force, final force. So now solve it, and before that you can apply boundary conditions. Boundary conditions, what are the boundary conditions? See, U1 is 0 and U4 is 0. U1 is 0, U4 is 0, and also see P2 is what? P2 is 10, P2 is 10, P3 is what? P3 is minus 20, it's left side. P3 is minus 20. So remaining is U2 and U3. Solve it. Solve it. Two equations, two unknowns. So U2, U3 unknowns. Second equation, third equation. You already know P2 is 10. This is minus 20. This value is 0. This value is something. You can solve it and you will get U2 and U3. So what is U2? So now you will get U2 is 0.49 something or 0.5. You can write it. Minus 3 centimeters. U3 will get it 3.48 into 10 power minus 3 centimeters. You will get it. Later you can solve P1 and P4 also. So what is the P1 value? P1 value is minus 28.8 kilonewtons. So P1 you will get 31 kilonewtons. P4 is minus 28.8 kilonewtons. Maybe you can check it is, I don't know. So those are the values, you will get it. So both are minus, you can see it will get this value, this will be also this value. Okay, P1 and P4. You can find out the stress in the element 1, stress in element 2, stress in element 2 also. I don't want to find out those values because it's already crossing 1 hour. You can check it. Once you find out the displacements, forces, that means forces means these are the reactions forces we are giving and reactions they are giving to us, and you can find out the strains in the elements and stresses in the elements, then only it completes the analyzation of the problem. Up to that we can't say it's over. Okay, you can find out the delta 1, delta 2, delta 3, and you can solve some of the problems also. So assignment problems like like this 3 by 3, you can solve it. There is no temperature. You can one problem is absent. So it's a 20 kilonewtons. Its length is 300 mm, 200 mm, 300 mm. Area is area 1, area 2, area 3, a1, a2. It's 2000 mm square. 2000 mm square. This is 1000 mm square. So Young's modulus is something. So same thing. 20 into 10 power 6 Newton per centimeter square. That's mm square. You can get mm square. So centimeter mm. So 10 to 20 power 4. So 20 into 10 power 4 Newton per mm square. You can choose it. You can choose any value and solve it and find out the stress reactions. Find out the reaction at this location, find out the stress in each elements. You can solve. You can took so many problems in strength of materials. You already did in strength of materials. You can choose those problems and solve it by the finite element analysis. Very easy. So okay, that's it. It's a closed by axial element. Next class we will see the truss element. Okay, that's it.